Okay, this is for the kids that are going to retest in class. So we need to look at number one. It says, which of the following sets would not form a triangle? So this is the one where you have to look at the sum of any two sides. So if I look at A, 8 plus 5 is 13, and that's bigger than 10. So we know that so far so good on that one. Okay. Then I have to check 8 plus 10, which is 18, which is bigger than 5. So far so good. And then I have to do 10 plus 5, which is 15, which is bigger than 8. So that's going to be a triangle. So what I'm looking for is the one that doesn't, the two sides are smaller than the third side or equal to. Because if it's equal to, it's just a flat line. So if I look at B, 12 plus 15 is 27. That's bigger than 26. 26 plus 15 is bigger than 12. And then 26 plus 12 is bigger than 15. Then we look at D. 4 plus 5 is 9. And those two are equal. And I can't be equal. The sides can't, two sides can't be, the sum of two sides can't be equal to the third side. So that's my answer. Okay? That's the one that does not make a triangle. Now for this one, this is the one some kids I guess get messed up on. I'm trying to find out if it's acute, obtuse, or right, or obtuse or right. So c squared and a squared plus b squared are what you have to put in the calculator. Okay, c squared or c is always the biggest side. Okay, so I'm looking here. C is 13, so c is 13. So 13 squared is equal to 169. 5 squared plus 12 squared is equal to 169. So this is a right triangle. Okay? Remember, you're always checking c squared first. All right. This is getting a little jumbled, so I'm going to go ahead and erase this and go to the next one. Remember, c squared is always the biggest side. So 8c squared, 8c. So 8 squared is equal to 64. And then I have 5 squared plus, so I have 5 squared plus 7 squared. So that's 25 plus 49. And that's going to be 74, I think. 25 plus 49, 74. So c is small. C squared is smaller than a squared plus b squared. So this is acute. Okay. And then the last one. 9 is c. So I have 9 squared is equal to 81. And then I have 7 squared plus 3 squared. That's 49 plus 9 is 58. So c squared is bigger. So this is obtuse. And that's how you do those. Okay. All right. AD is the median. Okay. So AD, that's the median. We'll draw and make this a nice little letter here, or a nice little line. Okay, AD, that's the median. That means it cuts it in half. All right. So that's congruent to that. It means I'm going to be equal to. So I'm going to rewrite my equation. 5x plus 2 is equal to x plus 18. And then I'm going to solve it. So I'm going to subtract x from both sides. Okay, x minus x is 0 the 18 comes down, the 2 comes down, and then 5 minus x is going to be 4x. And then I need to subtract 2 from both sides. So that's gone. I get 4x is equal to 16. Divided by 4. X is equal to 4. Okay. And then I need to know what BD is, not BC. So this is only asking me for BD. You have to check these letters. That means that 4 gets plugged in, and I end up with 5 times 4 plus 2 is 22. All right. So always check what letter you're doing, what segment. Okay. RQ is an angle bisector, so that means that these two angles are congruent. So I get 3x minus 15 equals 45. I add 15 to both sides. That gives me 3x is equal to 60. So x is equal to 20. And that's all I had to do for that one. Okay. Now this is a perpendicular bisector. Because there's the 90 degrees, right? That's what that means. And this is bisecting because I've got the tick marks. Okay, so they're completely different from each other. You have to solve y and then you have to solve z. You don't do anything combined or any of that kind of stuff. So if I go with y first, I have y. It's bisected, so y minus 4 is equal to 14. If I add 4 to both sides, y is equal to 18. It's that easy. Okay? Z is a little different. Okay? 2z plus 12 is a right angle, so it's going to be equal to 90. So 2z plus 12 is equal to 90. Subtract 12 from both sides. That gives me 2z is equal to 78. I divide by 2. That gives me 39. So z is 39. Okay? All right. Okay, this one is a base angle theorem, so it's isosceles. Those two sides are equal, so that means that I'm 2x minus 1 equals x plus 7. So I subtract x from both sides. That gives me x minus 1 equals 7. 7 is the only thing that's left over there. And then I add 1 to both sides. X is equal to 8. Now it's asking for a lot of stuff. So for AC, here's AC. AC is equal to 2 times 8 minus 1, which is equal to 15. AB, so AB is this side, is just going to be 8 plus 7, which is equal to 15. And then CB is this bottom one. So CB is going to be 8 minus 4, which is equal to 4. So we get that, and we should know that 15 and 15, they should be the same because they're both isosceles triangles. And then we have the bottom, which is 4. Okay? All right, let's look at the next one. Isosceles triangle, angles are the same. So I have 180 minus 50, which is going to equal 130. So Z and W equal 130. But Z and W are the same. So all I have to do is divide 130 by 2, and that gives me 65. So each one of those are 65. Okay. There we go. All right, now it says complete the congruence statement. Remember, these have to be matching. The sides have to be corresponding. So if I go to ABC, so I'm starting with the two arcs, and I'm going towards the one line. So if I start with the two arcs and I go towards the segment, that's going to be KDI. Okay. This one is ABC, so I go from the arc down the side. That means I'm going to go from the arc down the side. So this is going to be AFC. Okay. And this is ABC. Okay, so I went towards the single letter, right? So I'm going to go, here's the single letter right here, or the double arc, however you want to say it. So I'm going to go D, C, B. Okay. Okay, on this one we have to decide what's being proven. Okay. So I've got by what theorem are we doing? So this is, it's the right angle and it points to the hypotenuse. Points to the hypotenuse. And we've got the center, the shared leg that's always the same. So this is hypotenuse leg. On B, we've got a center that's shared, side, angle, side. Okay. Vertical angles aren't given to us, but we've got to know that they're there. Okay, they're always there. So this one is angle, side, angle. Okay. Again, D, vertical angles. So I've got side, angle, side. Now this one, there's a shared side. I guess I should have been the one. Okay. So I'm going to end up with side, side, side. And then this one is nothing. It's just an angle and a side. So none. Okay. All right, let's look at this one. Okay, so this one gives me that E is the midpoint of AB. So here's AB. Let's see. Here's AB. Now, it tells me that's the midpoint. So I've got those two are congruent. And I also know that I've got C and D that are congruent. Okay. And I also have vertical angles. And the reason why I'm doing this is I don't know if that's a typo, but AC, that was just a bad statement. But I can still prove this way because now I have angle, angle, side because of the vertical angles. So I've got angle, angle, side. Okay. Now on this one, I'm not sure what happened either on this one. Maybe I cut something off. But there's not enough information with what they gave us to prove this. My hypotenuses are congruent because it tells me that AB is congruent to ED or DE, and that C and F are right angles. But that's all it told me, and I needed one more piece. So with what I have right now, that would be none. Okay. All right, last one, or last few here. We're almost done. AB, so the first thing I'm going to do is show that my reflexive side's in there. AC is congruent to AC. And then it tells me that AB is congruent to CD. It also says that AB is parallel. Okay? So as soon as you see parallel lines, the line that's parallel is always going to have an alternate interior angle with the other one. Okay, so now I've got side, so side, angle, side. Okay, and then with D, okay, let's look at D. Again, I've got a reflexive side, PY, and it says that X and Z are congruent, and it tells me that PY bisects XPZ. So here's XPZ, and it bisects XPZ. So now what I end up with is angle, angle, side. So this is by angle, angle, side. Okay? Now the good news is we threw this out and it's not going to be on the retest. So that's it for the retest tutorial. Okay? Once you get through this, then you can take the retest.